In the last video, I showed that I was able to take and load an operating system, and from that operating system I could run a shell command and load a shell, and I had that automatically then also loading up an application from the SD card into the shell and then coming back out to the shell. And I had commented that one of the next steps I really need to do here is get user input working like you would expect in a interactive type of shell. And that's what I'm doing in this video. Is I do have that basic functionality working. And I thought I would just kind of talk through the type of functionality I have in here so far, and kind of go through what it's taking to make that happen. I have my system booted up, and here on the right, what you're seeing is the VGA output being captured. On the left is just the serial debug type of output that I log things to for troubleshooting. Now on the right, you'll notice that when it boots up now, I automatically have it load the shell. So it goes straight from my operating system. And if you see the greater than symbol here, that is my prompt to tell me I'm within the operating system. It's set to automatically load the shell now, and when the shell loads, I know I'm in the shell because I have a $ for a prompt instead of a greater than. When it does get into the shell, it says, "Welcome to the R265 Nibbler shell. I'm at version 0.2, and it shows me the current date and time. And that's just really to help me, I guess, validate, my SPI is working, the not SD card, but the real-time clock is working. And this is important because when I do get into the FAT system, dates are going to matter. So I just want to make sure that as I boot things up, I see a good date and time, or catch that as an issue if it doesn't match what I'd expect it to be. And I also debug out to the serial window that I've loaded the shell. So here now, let me show you what are some of the things I can do. Now, first of all, I'll come over here, and if I do things like just type a question mark and get help, this is what I have for functionality currently. So, I can type a question mark or I can type help. Now, that obviously means that I can come in here and I can type in things. So I can be sitting here at my shell and I can type in, maybe here there's some bad command, there's no such thing. So if I run that, it just tells me it doesn't know what that is. I can, do things like clear the screen. So CLS clears the screen, and then maybe I'll pull the help back up. I can do a version. I can do a directory, and this is actually reading off the SD card. So I can see what's on the SD card. And I include the last modified date and time, and then that column that says 25, 1299, 5537, those are sizes of the files. Or if it's a directory, there's a hidden directory called system something from Windows, but it obviously shortens it to the 8.3 format here. Oh, let's see, after that I can do a delete. So let's see, I have a file 7. So if I say delete file 7.txt, it says it found it, it deleted it. It should be able to verify that with a dir, and I can see it is gone. If I do a help again, I can do a copy. So I can say copy, I'll say copy file 1.txt to rich.txt. And then I can do a directory, and I can see there's now a rich.txt with the current time of 11:19 p.m. So that is all working fine. Go back and type help again. I can rename files. So I can say rename rich.txt to old.csv. And I can see that has renamed that just fine. I can run my GFX test, so I'll type in GFX test and run the same graphics test, or a subset of the graphics test I had previously shown. This one now I go down to 2x2 pixels. I don't go all the way down to 1x1 just because it's so slow, but drawing this pattern from 8x8 pixels to 4x4 to 2x2. And then I come up to that, I pause, and then I clear the screen. So that's just a little GFX test that's built in here. So I can kind of, anytime I want, just run that, make sure it looks like things are working the way I'd expect them to work. Other things in here that I could look at, there is a type. So when I did a directory, I can say type, show me what's in file1.txt, and that's what it does. Or I could say, show me what's in this gfxtest.hex, and that's what it shows me there is what's in there. Go ahead and go back to help. I'll come back to the run commands here momentarily. I do have date time, which will just simply show me my date time. I do have a set date time that lets me set the date and time. And basically it's just set date time, and then it'll give me the syntax. And for now, I'm just asking the user for the year, the month, the day, hour, minute, second in that format with spaces. So, which it obviously to do a little string parsing, it's not a big deal at this stage, but that was quick and easy. Besides that, I have a mem dump. So now I can do a mem dump, and it gives me the syntax of that. So I can say, well, go out and show me what's at address 0. And this is how many bytes of data I want. And I normally would type 0x in there, but I just typed 1000, same thing. But here I can see I write it out to my serial output. So in my serial output, I start with address 0 on here, on my system, the memory map, and I just started writing out, what it had all the way up to F0, and then it looks like there's a bunch of blank space, and then there's a whole bunch of stuff, and I can kind of work my way through that. If I wanted to go look at my reset vectors, I could say, well, do a mem dump and go out to, let's see, I'll go FF00. And I will ask for that much. And if I come down here at the bottom, it should have spit that out, which you can see right here. So I've got a bunch of reset vector locations that I'm going to jump to if I hit any of those reset vectors. And I can go to any other spot in memory, of course, and just anything that is addressable in the system, I can dump that out. And that's actually already been handy as I've been doing some troubleshooting, especially as I'm trying to load up C apps or different apps into different address spaces and check, are things getting loaded into the right spot. Other things I can do, I have, let me just clear the screen and do a help again. There is a run hex, a run bin, and a load. Now, if I do a directory, I've got hex files and bin files. This GFX test hex is basically written in C, and then I basically compiled and linked it out as a hex file. And if I want, I can tell it to load that hex file. And it just simply loads it into memory and tells me what the jump address is. So where is this if I want to go look at it? And I might do this like with a mem dump. Now I might go out and say, well, I'd like to look at what is at 1980. And however much I want to look at. But that'll show me at 1980 what is the start of that. I'm using Calypsy, so whatever it has as its initialization routine. Again, I'm dynamically looking at this Intel hex format, figuring out where the start location is. And in this case, it tells me in 1980 is what it found. And now I can look at what did it actually copy from the SD card into RAM at 1980, and I could look through this. And if I was to look further through this, I would then see that it also, or I know that it also copied over to like my bank 3, the actual program. So the initialization is down here in bank 0. The program's whatever this hello or GFX test is up in bank 3, and I could go take a look at that. So if I said, well, give me a mem dump, go out to bank 3, maybe just the beginning of that. So 4 zeros, and this is how much I want back. And then it comes back and shows me what is there. And of course, I can then compare that with what's on my PC as I actually built these files, make sure that all the right data is there, things like that. Now, if I actually wanted to run it, I have a command up here that is a run hex. So I would just say run hex and then gfxtest.hex, and it would load it, but then it would do that jump. Now, I've been running into struggles with that, getting Calypsy to basically compile and link in a way that I can load this and not cause conflicts with my shell. There's just more customization I have to do to make that work. So that I'm not going to run right now because it actually will cause some stability issues with the system. And I've tried to isolate the stack and where all my data is, basically the direct page, everything. I've tried to move around and be free of my shell and OS, but I'm still running into something that just is weird. So I want to leave that one for now. But the other thing I have up here besides load and run hex is I can run a bin. And so these are bins, and instead of me using Calypsy, I just simply used Retro Assembler and did some 816 assembly, assembled it into a couple of bins. And they're very, very boring bins, but there's a hello bin and a buy bin. So if I want, I can just come down here now and say I'd like to run a bin, and I'd like to run hello.bin. And it just tells me it's loading it. It loaded it into bank 3, 0000 for the address within that bank, and then jumped to it. And all I'm having that do is write out hello to the screen. And I'll show you that. It's very, very, very simple program. And then it returns, does a return. Basically, I'm doing a long jump and a return, so RTL. And then it says, yep, back to the shell. And now I can come in here and I can say, well, let's go ahead and run bin by.bin. And just as exciting, it loaded it into memory. It jumped to it. What that code actually did was said buy. And then it returned. And then I, on the return, just say I'm back to the shell. So that is just taking files off of my SD card and running them on the fly, which is great. So I can have my shell do all kinds of things, but then some things that are maybe more specialized or infrequently used or really large, maybe I'll place those onto the SD card and be able to run them just with this run bin. Let's see, did I miss anything? So clear, version, directory, delete, copy, rename, graphics test, date, time, output, and setting. I did the type. So maybe the only thing I haven't done here is an exit. If I say exit, that takes me out of my shell, and now I'm back to my OS. So now if I do things like help, it's a different help because this is the help for my operating system. And if I want, I can go back into the shell by typing in shell, and it loads up my shell and again says welcome, gives me the current date and time that I can double check, and that all looks good, and I'm off and running. So that's the type of interaction I'm building, and as I'm doing this, I'm accessing the SD card. I'm using FAT16. I've got the basics for file IO running. So I can do a directory. I only support doing a directory of the root directory at this point. I don't support subdirectories at this point. There's no make directory, remove directory, or anything like that. But for now, that doesn't matter. I can put plenty of files in here, more than I need in the root directory. But I can delete, I can copy, I can rename all of that. And then in time here, I'll add some functionality to create new files, text files. I'll have to do some type of copy from the console or an actual text editor. So we'll see what that might look like if I can get a basic text editor in here and running. So that's the functionality that I've gotten, and that seems to be doing just fine. What I might do then is just kind of point out some of the code things, kind of like I've done in previous videos, just a real fast walkthrough, not trying to go through this in detail. I will post this entire repository of code on my GitHub if you want to walk through any of this. Now, a couple of things. First of all, I'm in this primary, and this is what I've been doing. All of my main board, this is its operating system essentially. There is a secondary ROM in here that is completely independent of the rest. I probably should just put it in its own folder so it makes that more clear. But primary is the one that drives my primary board. This secondary is the secondary ROM on my board. And in it is where I do put a copy of the shell, and then when it boots up, I load that shell. And so if I look at my primary, this is what it's going to process when I turn the system on. It's going to come down to this section down here and get into start 265. It's going to do all kinds of initialization, but then at some point as I get down here, I'm going to have it go ahead and jump to this address. And that's the address basically on my secondary ROM, where I have a routine that will load up the shell off of the secondary ROM and then jump to that shell. So that's basically how I get into my shell. And I can make this more dynamic. I could give this a friendlier name, but I just know it's out in bank 40 on my secondary ROM, and I put it at this 2E00. And I can go out here and look at my secondary ROM and find that address. So here's the 2E00. All of this code is in bank 40. The way it's mapped in the memory. So this is really 42E00. So that's what I jumped to. It's a shell loader. And that shell loader I mentioned in the last video, this is basically taking and dynamically loading a hex file that is, basically a compiled output from my C, Calypsy, and then loads it, runs it. Well, that C Calypsy is down here, and that's under my source, all my C projects, and it's shell. And you're now going to notice I have quite a few files down here, or more than I did before. So before I had everything in shell, but what you're going to notice now is I've started pulling out functionality into separate files with headers, and so I'm including those. So I've got graphics, utility, operating system, file system. So if I go to the file system header, these are the types of things that are in it. Having to do with the SD card, reading, writing, manipulating that. And then, of course, the actual routines are over here in the C file. Same with the graphics. I've got some graphics routines over here. The OS has a lot of my routines that make the cop calls. So the cop instruction is how I'm accessing from my shell back to the operating system to get to the hardware. And then I have utility, and so a whole bunch of just different types of prints from one format to another, or converting different formats, or doing delays, things like that. And then there's the main shell. In addition to that, there's this rules file, which I've continued to tweak. And this is basically where I'm setting up the memory. So what's available, and basically the way I have it set up right now is that, and actually I put this in primary as some notes up top. This is what I'm doing at the moment. So the OS, I'm giving it from basically 0 up to, let's see if I've got it marked here. I might not even have it marked here, but I'm giving it up to 17FF. And I was just looking to see if I wrote that down in here. It doesn't look like I did. But then the shell, it can pick up at 2000. So I think technically up here I can go higher if I want, and give my OS a little bit more space. But I'm giving it up to 1800 essentially. 1800 up to 2000 is free at the moment, at least according to these notes. And what I want to do is check my rules down here. And this is telling me that the C shell, what is it taking for space? So it's going to start at 2000. So it's 0 pages from 0 page or direct pages from 2000 to 20FF. And then right after that, I go from 2100 to 5FFF for RAM data. Code, I'm going to put way up here in bank 1 and give it quite a bit of space, 128K there. If I come down to the RAM, it's getting, let's see, 2, 3, 4, 5, 6. So 5 times, 1K roughly. So that's how much memory it's getting to work up there. Let's see, did I do that math right? No, it's 5 times 4K, so 20K. And if I wanted to, I could open up a calculator just so that I'm not too far off on this. But if I look at hex, and then I can do 5FFF minus 2100 and then +1. So that's how much space. So 16K roughly of space that I'm giving the shell for its data. Code-wise, it's got plenty of space, and then of course it has access to the flash if it needs to get to the primary flash. But it could access the secondary flash if I wanted it to. But this is just all configuring, what parts of my code can be placed into what areas of memory. And I'll continue to be tweaking that, but that's how it sits right now for my shell. Now the shell, the way that it's working is basically when it comes up, it jumps down to main. And, I initialize the FAT system. I put out that welcome message and a version, and I display the date and time. I run over to my serial output and say that the shell is loaded. I put out a $sign as my prompt, and then I just get into a loop. And all that's in the loop right now is a keyboard check. Maybe there'd be other background tasks I would put in here. But this keyboard check is just like it sounds. It's constantly just checking, are there new characters that the user has typed? And I have an operating system call, which is a cop call. So I have a cop hex 10, and that just simply says, give me a character if there's a character queued up for me to process. And once it gets it, it can check, was it an inner key? If it wasn't an inner key, just kind of let the keys keep building up in a buffer. And once I do press enter, then I basically process that. So if there's actually something the user typed in, then I have an execute command. And in the execute command, I can go through and see, is it a command that I support? I have a table of supported commands right here. So I can add, just keep adding to this list. Really easy to add to that. I can add a reminder in my little help output, just so I know I can remember what do I support as I'm in the different shells that I might build in the future. But then let's just say I was in here and I did a dir, then it's going to go ahead and run this cmd dir. And in this case, it's first going to see if my FAT is initialized. If it is, I have a procedure called list directory, which is over in this file system. And then, there's the implementation for showing me the files on that SD card, which of course behind this, then it's doing SPI and things like that. And so, if I get into any of these, like SD card read sector, if I just keep following this trail, when I get into that, it's eventually getting down to a cop call. So everything from my shell to my hardware, other than direct RAM access, I'm really trying to do through cop calls. So when it comes to reading the SD card and all the SPI behind that, that's down in my operating system. Here, I just simply say cop 11, and I am keeping track of all my cops in this. And so this is the list that I have right now. Not all of these are implemented, but most are. Draw a circle, line, and pixel are not done yet. Will not take me too long to put those in, but I just haven't filled them out yet. But you can kind of see some of the others I've been adding. Now, see all the SD card, the get date, the C app return, which I'm not even using anymore. The get keyboard characters that are queued up in the buffer. And now I've added support to print out to my serial in addition to the VGA, and then also to set date and time. So the OS supports all of these. My shell can then call all of these just with the cop call. It doesn't have to know where in the OS they are. It just says cop number 15, and it has to have some parameter data passed along, but then my OS just simply sets the date and time on the SPI real-time clock, and I really don't have to worry about anything else from the shell side of things. So now I have all of these files, and that did mean that I had to come up here and change how I actually do my build. So this is getting more complicated. I've added a clean task that just wipes out all the files that are in the build folder, but then I have to compile each of those separate C files down there. So I compile the shell, the graphics, the utility, OS, file system, and then I link it all. And then I also have a separate build that builds this other C application in here, this GFX test, which, like I said, I'm struggling to make that work right. And I might even abandon trying to have a second Calypsy compiled and linked program load, or I'm going to have to do some modification to how it would normally behave, I believe. And I've not wanted to do that quite yet. And then I have basically a task Calypsy all that does all of that, right? So it's going to do the clean and the shell, graphics, util, OS, file sys, and then link it. So that way, when I am in here and I'm modifying all of this stuff and I come down to the shell, I can just hit Control-Shift-P. I can tell it I want to run a task, tell it to do a Calypsy all. And when it does that, it will erase everything in the build, and then it'll start just filling them back in. So it builds them. It gives me the listing file for each of the compiled C files, and then it'll give me a listing for the overall shell, which is right here. So it looks like that's done doing that, and I now can come into it. And I can start to look at, what are the memory sections? Where are they at? Are they where I think they should be? I can figure out how much of my space is used. So like here, I'm using this 2000 to load my shell. And I can see that, well, within that first 256 bytes, I've used about 8% of it. And then my RAM data, I mentioned that calculation earlier of how much I have. I'm using 48% of it right now. I can come down and see that if I get out into my bank one, I've got two separate 64K chunks. The first one is less than a quarter used, and the second one isn't used at all yet. So lots and lots of space out there as I want to use it. And that would be in this bank one and bank two that I've given it. And then it gives me all the other details about, what got placed where and things like that. So really helpful for debugging. Now, I also had, done the running of an application off my SD card. So I come back over here and let me just clear the screen, and I'll do a directory. And again, I saw that hello.bin, and I just simply say I'd like to run a bin called hello bin, and it does that. So the program itself, all it did was say hello. Everything else was coming from the shell. I just said, okay, I'm going to load this file. And basically, I'm finding it. I found it. I'm loading it. I'm copying it over to the appropriate spot in memory. And then I'm going to jump to it. It runs. And when it returns, I then say back to shell. So if I come back over here, all that functionality I put in. So in my shell, when you do press enter and it figures out which command, it jumps to one of the appropriate commands with the help of this jump table. But if I said I want to, for example, do a run bin, it does the CMD run bin. I can then go look at, what does it do? But it basically is going to leverage this routine that is going to load up whatever file I give it into bank 3. And then once it's done with that, it's going to actually jump to it. And, of course, I can go look at what this looks like in my file system. What is it doing to load up that from the SD card? And again, there are things as I get down here like read sector. I'm going to eventually get to a cop call that's doing all of the work with some 512 byte, one 512 byte buffer that I'm using to really move stuff back and forth between the SD card and the rest of the system. So that's the gist of what I'm doing right now. If I did go and open up these apps, here's the hello. That's all I have in there right now, is just simply saying load up an H, store it in. This is a location that I've set up kind of as a parameter data section between my OS shell and apps. If you want to call it a mailbox, it's kind of a mailbox. So this just says put an H in the mailbox, call cop1. Cop1 is a print char essentially. And then put an E in the mailbox, call the print char, and just work its way through that. But that app doesn't have to know much. It has to know my cop commands. And I could definitely, if someone was developing for this, I would share out and say, well, here is, a list of cop commands. You can just, maybe I turn this into an include or something, and you just include, and you've got all the cop commands. I didn't do that yet. I'm just in my actual hello, I just know cop1 is whatever, but I could, of course, include that other file and then use the friendly name if I want to say that I want to do a print char instead of this one. But, standard interface, it's not going to change. The biggest thing that I'd have to be careful of is changing this address because that would cause some headaches. But if I want to change where the cop calls are at on my OS or what they do inside of them, I can do that without impacting anything that calls a cop1. As far as it's behind the scenes, what it doesn't matter. Its interface is going to matter, but this cop call makes it really simple to do that. If I go over to the buy, it's pretty simple too. So it's just simply loading up the characters to say buy, putting them in these mailboxes and calling the cop instruction for the print char. And again, over here, cop1 is print char. Cop2 is a new line, et cetera, et cetera. And I've actually added functionality now so that when I do a print char, if it finds a carriage return in the string, it automatically does the same thing as a new line. So I don't even need new line anymore. I can just do print chars and send it carriage returns. So those types of things I'll continue to clean up as I go. So I think those are the big things right now that I've been working on, and this continues to be, this is running well. What's not running well and has been tricky is if I compile a second C app, I try to load it. You saw that in the last video, I've done it, I've made it work, but as I'm trying to build something just naturally in C and I compile it, link it, and try to load it up into memory, all with its own distinct spaces of memory. So there should not be any overlapping, its own stack, its own direct page, its own memory for everything that has no overlap. It still runs into some just weird issues. And it's likely something I'm not understanding, or it's something within Calypsy that I need to figure out how to better control. But Calypsy is working great when it comes to my shell. So, all of this shell is being done in Calypsy, and that is working quite nicely. And I'll be able to now just start adding additional C files and header files, including them, doing my build. And once I do the build down here, that makes really a hex file. I then come up here to the secondary ROM, and I include that hex file just inside of the ROM. So here I would just do a build. I did a Control-Shift-B, but now that hex file is embedded into my ROM. And then this is all the code above it that dynamically reads that hex, puts it into memory, and jumps to it. I'd say quite a few moving parts here, but now that the parts are there and they're working, I can move pretty rapidly through this C code. It's pretty straightforward to come in here and do. Again, I'm not great at C, but there are tons of resources out there and tons of example code or libraries, things that I can look at to understand how to do different things. And this type of stuff goes really fast. So if I need a certain function, it seems like I can crank through those functions pretty fast. And you can, again, see the types of stuff that I've got in there so far. But I'm at a bit over half an hour here, so I'm going to stop at this point. I'm not sure what the next step is, but this is another good milestone, I think, in building an OS here for my 65265 build. And we'll see what doors this functionality here opens up as I want to continue forward.